Hello students, let us continue with exercise 6.2 of chapter 6 lines and angles. Until the last class we completed 4 questions. So we will take a look at the last 2 questions now, which is 5 and 6. So the 5th question, we have line AB parallel to CD. So these 2 lines here are parallel. Angle APQ is 50 degrees and angle PRG is 127 degrees. We need to find the values of angle Y and X. Now this is a very simple sum. So if you notice, I have AB parallel to CD, correct? And if I take a look at this transversal for the 2 parallel lines, that is PQ, I have a Z forming here. See, there is a Z, correct? Which means this angle and this angle are a pair of alternate angles, therefore they are equal, because alternate angles for parallel lines are equal. Therefore angle X is going to be 50 degrees. Let us write this down now. I will say solution. AB is parallel to CD given. Therefore angle APQ is equal to angle is equal to X, correct? Because we need to find the value of X, therefore I am just writing X. I will say why? Because alternate angles. But angle APQ is 50 degrees, therefore X is equal to, but angle APQ is equal to 50 degrees, correct? Therefore X is equal to 50 degrees. I will mark this as 1. So we have found the value of X. Now let's go ahead and find the value of Y. So now to find the value of Y, we will take into consideration the transversal PR. I have lines AB and CD parallel and PR is the transversal. So if you notice, I have a Z here, correct? So this angle and this angle are equal. That means angle APR and angle PRG are equal because they are alternate angles. So therefore this entire angle would be 127 degrees. Therefore obviously this angle Y, this smaller angle Y, it's going to be 127 degrees minus 50 degrees. So let us solve this now. Now AB is parallel to CD. I just missed out to write the transversal here, and PQ is the transversal. Correct? Because we are considering 2 different transversals for both the for finding the value of X and Y. That's why we mentioned the transversal. AB is parallel to CD and PR is the transversal. Therefore angle APR is equal to angle PRD. I will say because they are alternate angles. Correct? But angle PRG is what? 127 degrees, and I will write APR into, I'll split the angle. So I'll say angle APQ plus Y, correct? And I'll say this is 127 degrees. I'll say because angle APR is equal to angle APQ plus Y, and 127 degrees, that is angle PRD is equal to 127 degrees is given, correct? So therefore Y will be, now APQ is how much? APQ is equal to 50 degrees plus Y is equal to 127 degrees, and here I will say that angle APQ is equal to 50 degrees, it is given. Correct? Now get your 50 on the right hand side. Therefore you get Y is equal to 127 degrees minus 50 degrees. So this is going to be 7 and 7, 77 degrees. And I'll mark this as 2. So your answers are going to be 1 and 2. I'll say answer X is equal to 50 degrees and y is equal to 77 degrees from 1 and 2. Right? So this was the solution to our question number 5. So now let us proceed with question number 6. This question looks a little theoretical and it is related to a little bit of your physics where you must have learnt about light. So first of all, you need to know that if I have a polished, well polished surface and let's say a ray of light strikes on this polished surface. So it is called the angle, or it creates, and if I draw a normal to this line, if there is a perpendicular on this line, right, if I draw a perpendicular on this point, this angle is called the angle of incidence and it is represented by I. Why incident? Because the ray is incident at this point, okay, I'll call it point P. And now when it strikes, obviously, when if you must have noticed, if you've kept a mirror you know, under the sun, and the light strikes on it, the light reflects back in this direction from the polished surface and it makes an angle with the normal. Why? This line is called the normal because it's the perpendicular to the polished surface, and this angle is known as the angle of reflection, and you need to know that angle of incidence is equal to angle of reflection. Right? So now let's read out our question. We have PQ and RS are two mirrors. I have PQ and RS are two mirrors and PQ is parallel to RS. That means PQ is placed parallel to RS, which means the lines PQ and RS are parallel. Okay, incident ray AB strikes PQ at B. So incident ray PQ incident ray AB strikes PQ at B, correct? So if I draw a perpendicular over here, the normal, what will I have? I will have this as the angle of incidence and this as the angle of reflection, correct? Now reflected ray moves along the path BC. So now see, we had this as the angle of incidence, therefore the reflected ray is here. The reflected ray moves along the path BC, correct, and it strikes RS at the point C, correct. So now if I draw a normal over here, correct, so for RS there is an incident ray that is striking at C, making an angle of incidence I, and it is reflected back. CD is the reflected ray. So this is the angle of reflection R, right? So let's read. Incident ray AB strikes PQ at B. Reflected ray moves along the path BC and strikes the mirror RS at C, and it reflects back and to move along CD. Now what we need to do is we need to prove that AB is parallel to CD. So we need to prove that this line AB is parallel to CD. Now please do not get confused when I have drawn arrows over here. Usually arrows are used to represent that the two lines are parallel, but the arrows here mean the direction of the rays. So the ray is moving along this path. So these arrows are indicating nothing but the direction of how your light is incident and getting reflected, the direction, okay. So first of all you need to know 2 points over here, that the angle of incident is equal to the angle of reflection and normals drawn to the angle of to the different angles are parallel. So you can say, if I name this point as S and T, I have SB parallel to TC, okay. So now we have SB parallel to TC, therefore what do I have? Angle R is equal to angle I over here. This angle is equal to this angle. Why? Because they are a pair of alternate angles, correct. Because these two lines are parallel, I have this angle equal to this angle. If you see, they are making a Z, correct. But what do we know? We know that the angle of incidence is equal to the angle of reflection. Therefore, this angle is equal to this angle and this angle here is equal to this angle, correct. Therefore, what will we have? We are going to solve this, but I am just trying to make you understand the concept. So do not panic if you are not getting it right now, while I'm explaining. Once I write it down for you, the concepts will be clear and you will find that the sum is very simple. So moving back, now therefore this angle is equal to this angle and this angle is equal to this angle. Therefore what do I have? Therefore I have this angle equal to this angle, correct? So what did we have? We have this equal to this and this equal to this. So when you add these two angles and these two angles, what do you get? You will realize that these two angles are equal. This entire angle is equal to entire this angle, just because I am adding them up. Therefore what do you get? That these are a pair of alternate angles. Alternate angles for lines AB and CD as lines and BC as the transversal. Therefore what you can say, because these two angles are equal, I have AB parallel to CD. Now let us write down the solution. First of all, things to remember. According to laws of reflection, we have angle of incidence equal to angle of reflection. So angle of incidence is equal to angle of reflection. Correct? So for this angle of incidence AB, I have angle of reflection for the reflected ray BC R, correct? So I'll call this I1 and R1. I have I1 equal to R1. Similarly, I will, for this angle of incidence for ray BC, I'll call this I2 and I'll call this angle of reflection as R2. Correct? So I have I1 R1 and I2 R2. So I1 is equal to R1 and I2 is equal to R2. So this is according to laws of reflection. Right? And the second thing to remember is perpendiculars drawn to parallel lines are parallel. So now let us write down our construction. I'll say draw SB perpendicular to PQ and TC perpendicular to RS. Correct? So this is my construction. Therefore, what do I have? According to this law, perpendiculars drawn to the parallel lines are parallel. What do I have? I have SB parallel to TC. Therefore, I have SB parallel to TC. Correct? Now, for parallel lines, SB and TC, I have a Z forming here, if you notice. So, therefore, I can say R1 is equal to I2. Why? Because they are a pair of alternate angles. So, therefore, angle R1 is equal to angle I2, because alternate angles for parallel lines SB and TC. Correct? And I'll mark this as 1. But what do I have? We know that according to the laws of reflection, angle of incidence is equal to angle of reflection. Therefore, this is the angle of this is the first angle of reflection. This is going to be equal to the angle of incidence I1. Similarly, for angle of incidence I2, I have angle of reflection R2 equal to I2. Therefore, what do I have? But I have I1 equal to R1 and I2 equal to R2. Correct? I'll mark this as 2. Therefore, what do you get from 1 and 2? From 1 and 2, I will get that I1 is equal to R2. Correct? I1 equal to R2. Therefore, angle I1 is equal to angle R2. And I'll mark this as 3. Right? Now, if you add these two, what do you get? adding 1 and 2. If you notice your equation 1 and equation 2, what do we have? We have two equals, right? So if equals are added to equals, the wholes are equal. So let's say I am adding the left hand side of this with the left hand side of this and the right hand side of this with right hand side of this. So obviously they are going to be equal. Therefore I have angle R1 plus angle I1 is equal to angle I2 plus angle R2, and I'll say this is from 1 and 3, correct? But R1 plus I1 is what? It is this entire angle ABC. Therefore I can say angle ABC is equal to I2 R2 is BCD, correct? Is equal to angle BCD. So if you notice, angle ABC and angle BCD are a pair of alternate angles for lines AB and CD and transversal BC. So what can we say? That since the alternate angles are equal, we have lines AB and CD parallel to each other. We do not have much space, so I am just erasing this section over here. But angle ABC and angle BCD are an equal pair of, or let's just say are a pair of alternate interior angles for lines AB and CD and transversal BC, correct? BC intersecting AB and CD at points B and C respectively. Therefore, what do we have? Therefore, what can we say? That AB is parallel to CD. Why? Alternate angle theorem. Therefore, we have proved what was required, that AB is parallel to CD. Here is the remaining section. Please take a look. So I hope you found this exercise easy. We will wind up with exercise 6.2 now, and we'll take a look at the remaining chapter in the forthcoming classes. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.